Alright, the live stream is up. Quality looks good. Let's get the video up and running on YouTube. Alright, I can hear my voice. Don't want to hear myself though. Alright, we'll give it a bit. As you guys are coming in, go ahead and just let me know that you're here on the chat box. Even though YouTube says, oh, these people are viewing, I don't always know who is viewing, so that'd be helpful. I'm actually kind of curious now to try something. I don't know if I can even change the settings while I'm doing this. No, I can't do it. It's going well, Blake. I'm a little tired, but it's going well. Got back from school, doing the live stream here. I'm gonna have dinner as soon as we're done with this. Thinking maybe just having a sandwich. Yeah, I'm almost ready, Isaac. I'm just gonna give people some time to jump in. The only thing we'll be doing in this video is working on the green packet, which is kind of weird because you're seeing it blank, or sorry, not blank. You're seeing, you know, the problem right here, and it's on white paper, but on your guys' paper it's green. So yeah, we can help you, Isaac, no worries. Okay, so you guys know the general rule of thumb. If you guys have a question on a specific problem, just go ahead and let me know in the chat box, and we'll just kind of go from there. Right now it says I have 5 people watching. I think, can I edit the video while it's streaming? I think I can, because I want to change this title. Yeah, I can change it. Sweet. Let's see here. Cool. Did it save the chat box though? That's the question. Yes, it did. That's awesome. Alright, I'm ready whenever you guys are. Just go ahead and give me a problem to start with, and I'll go ahead and help. Number 4B. Sure, Isaac. So we're looking at a pyramid of a sort, and this pyramid has a base of a hexagon. So we're asked to find the surface area and volume. Now I will apologize in advance for the box being small. Not a lot of room, I understand. So let's go ahead and tackle this. Now let's start with the surface area. Surface area requires that we figure out the lateral area. I'm going to answer that real quick. difference. Yes, Zach, after that one I can do number 7, of course. So let's go ahead and try to find the area of our base first, because we will need that area in a bit for the other two parts of the problem. So since it is a hexagon, I know that I'm going to end up using my 1/2 AP formula. So that means that my side length down here is 4. And then by drawing in my height, oh, what? That was weird. Okay. And then drawing in my height there, that's going to be our apothem. And we know that that's going to split it up into 2 and 2 a piece separately. Now, I have to remember, and I can't forget, that you're going to find this angle up here first before finding those two angles separately. So remember that we're going to be doing 360 divided by 6, because there are 6 sides. And then you're going to take half of that. So that means each of these angles are 30 apiece. So now, using our special right triangle, what's up, Jonah? We have that the apothem is going to equal 2 rad 3, because that is our long leg. Long leg equals short leg times rad 3. So the apothem is 2 rad 3. We can find the area of our base, because we know that this is 1/2 AP. So that's going to be 1/2 of 2 rad 3 times our perimeter, since there are 6 sides. Each side length is 4. 6 times 4, 24. So that is going to be 24 rad 3. Now let's go into the actual part of this, the surface area and lateral area. Lateral area, we know, is for a pyramid 1/2 perimeter times the slant height. So our perimeter we just established was 24. So 1/2 of 24 times the slant height, which is given unto us, this 8 right there. So that should give us a 96. If I take half of 24, that gives me 12. 12 times 8, 96. Going into surface area. Surface area is going to be the lateral area plus one of our bases. We already did the work for the base, so this is just going to be 96 plus 24 rad 3. And literally that would be your answer. Can't solve the volume. Okay, we're going to go ahead and do that, Isaac. So if you guys notice that the apothem goes from the middle of the side here to the center of the shape, that actually helps us create a right triangle to solve for our height. The slant height was already given unto us. So that's going to be 8, and our apothem is 2 rad 3. So in a right triangle off to the side here, nope, wrong one. 8 goes here, 2 rad 3 goes there. These equations, Blake, I'm giving to you on the multiple choice part of the final. For the free response tomorrow, you guys only have to have memorized the formulas for prisms and the volumes and surface areas of pyramids. Okay, we need to solve for h. We're going to go ahead and set up that Pythagorean theorem, Isaac. So h squared plus 2 rad 3 squared equals 8 squared. If you want to type these in your calculator, you're more than welcome to. I'm going to do these by hand. 2 squared is 4. The square root of 3 squared is just 3. 8 squared is 64. So then I have h squared plus 12 equals 64. So then h squared is going to equal 52. We're going to go ahead and take the square root of both sides. So then h is going to equal, let's see, the square root of 52. I think that's 13 times 4. 13, 26, 39, 52. Yep. So the square root of 4 times 13, which I know that the square root of 4 simplifies to 2. The 13 I leave alone. So now, Isaac, using the height right there, we're going to find our volume. So our volume is going to be 1/3 the base area times the height. So 1/3 of 24 rad 3 times, what did we just say that was? 2 rad 13. That'll be fun. So let's see, 1/3 of 24 is 8. 8 times 2 is 16. The square root of 3 times the square root of 13. Both are prime numbers, so I know I can't reduce them afterwards, so it's just going to be the square root of, so I don't know why I did that, 39. So 16 rad 39. And so that is our volume, Isaac. All right. Now, Rough McGruff, you said you wanted to do number 7, so we're going to go ahead and do that. I'm going to give people a chance to copy this down who need it. Why is it 2 rad 3 on the bottom? For which one, Zach? Are you talking about the base area? Or you're talking about for the triangle? I'm assuming you're talking about for this triangle. And the reason it's not a 2, Rough McGruff, is because the triangle that I'm looking at is cutting inside. Okay. So it's cutting inside of the pyramid. I'm not looking at the face of the pyramid. I'm cutting inside of the pyramid, like cutting into a cake. So that triangle there, this is your apothem. That was what we found over here. That's why it's 2 rad 3. It's not just 2. The 2 would be going this way. That would be a 2. And so would this. But I'm not looking on the face, I'm looking inside of the triangle. So I hope that was of help to you. Okay, cool. So let's go ahead and take a look then at number 7. We already did 5, there's 6, 7, okay. So I know we never formally learned what a frustrum was, but a frustrum is just a word that essentially says it's a section of a cone, or it's a section of a pyramid that doesn't include the top. So frustrums would be things like pails, or usually certain kinds of containers that are essentially going downwards. What's up, Dylan Rogers? So we're going to go ahead and find this volume of this beautiful frustrum. Now, I gave you a little hint here by stating how we're going to find the volume of said frustrum. We're going to find the volume of the entire cone. And then we're going to subtract from it the volume of the small cone. So we're going to go ahead and set those up for us. So the height of the original cone is 18 with a circumference of 12 pi. I need to find the radius from the circumference. So for my big cone, we're going to go ahead and say that our circumference is equal to 2 pi r. So 12 pi, yes, I don't know why the pi's came out weird in this, but 12 pi is going to equal 2 pi r. So if we go ahead and divide both sides by 2 pi, we're going to go ahead and find that r equals 6. Now, since I know the radius of the cone as well as the height, we can go ahead and say that the volume of the big cone is going to equal 1/3 pi r squared h. So 1/3 pi times 6 squared times our height of 18. Now, I know you guys are going to hopefully try to do this on your own. Go ahead and do that and tell me what the answer is on the group chat. As much as I'd love to do this in my head, you guys need to practice, not me. I already got my college degree. Now, while that is going on, what's up, Celestino? While that is going on for the big cone, we're going to go ahead and take a look at the little cone. The top portion of the cone that was removed has a height of 6 and a circumference of 4 pi. For the small cone, let's go ahead and use blue. Michaela, we do have to have the formulas memorized for tomorrow. However, I will go over the ones you will need before you actually take your free response final. We're going to say circumference equals 2 pi r. Our circumference was 4 pi. So we will say that 4 pi equals 2 pi r. So then dividing both sides by 2 pi again, we get r equals 2. Yes, Zach, it would be 216 pi. And if you're wondering, yes, I did do that in my head. That's not a good pi. But so our radius here is 2. Let's go ahead and use the same formula. So we're going to say 1/3 volume equals 1/3 pi r squared h. So that's going to be 1/3 pi 2 squared times, what did we say the height was? 6? Yeah, 6. Because, Elijah, if you read the question, it says, I give you a circumference, and the formula for circumference is 2 pi r. Ah, he retracted his message. He learned from his mistake. What a concept, guys. What a concept. Yes, we do use 2 pi r because I give you the circumference. If I gave you something different, like I said, the area of that circle was something else, you would use the area formula of a circle. So anyways, hopefully you guys are doing this one here. I'm not doing it. I need you to do it. Figure it out. What is the volume of that cone? The small cone. Yes, Ethan, when we get around to it, we will do 6a. Of you are watching, yay! It's actually kind of cool. Eight pi, my boy Zach Ruff McGruff. Oh, what the heck? Okay, so now going back to what we ultimately were trying to do, we're trying to find the volume of the leftover section. Now I'm going to change this because as much as I'd like to say the entire cone, let's be honest, we're going to say the big cone. So the volume of our big cone we said was 216. Yes, it would be 8 pi, Dylan. 216 pi minus 8 pi, which should give us a grand volume of 208. Now, because we want to be good mathematicians, we need the correct units. They were given to us as inches. So therefore, 208 inches, pi inches. Cute. There's our volume. Yeah, Elijah, you have to not type pi into your calculator. Because especially if I ask you give me the answer in terms of pi, I want the answer with the pi still in there. Silence my phone because, knowing my luck, someone was going to message me. There we go. What's up, Sarah? So now, McCune, we're going to go ahead. Sorry. We're going to go ahead and jump to number 6, right? Why can't I see where his question was? Yeah, 6a. So let's take a look at 6a. All right. So right here, what's up, Nick? We're going to go ahead and do the same question, same type of question that you had on your test for this one. Now, some of us are so used to using formulas and trying to use equations that we forgot to use our noggin. Okay, we're painting the outside of this house. So two things are going to happen. One, you are not going to paint the bottom of your house. You are not painting this. That is a no-go. Okay, the other thing too, you are not painting the roof where the shingles are. So you are not painting this surface, nor are you painting that surface back there. Those are no-goes. You are not painting those. Instead, what you are painting is going to be the triangle that is in front here, the triangle that is in the back there, and the faces that go around the prism. So you have a couple of ways of looking at this. You could say, well, Mr. T, I want to find my area of each of those faces, then add them all up. You can totally do that. Totally feasible. You could also say, Mr. T, I want to find the lateral area of that prism and then add the area of the triangles. You're more than welcome to do that too. I'm okay with either approach. Personally, I like using the lateral area. It's just nice and clean. So let's go ahead and do that. So I'm going to need the perimeter of my base. I know for a fact that this 14 here translates to here. This 9 down here translates right there. So my perimeter for that, nice job, is going to be 9 plus 14 plus 9 plus 14. I'm going to write it this way though, because it's just a little easier. Now, since Ethan McCune asked the question, he needs to give us the answer. So whenever you're ready, McCune, tell us what that perimeter is. While he is doing that, I'm going to write out the equation for our lateral area. The lateral area of the prism, the bottom part. Do we include the plane parallel to the ground? No, you do not. You are not painting either of those. I don't remember if I told you guys this. I might have, I might not have. The theme of your test tomorrow involves pyramids. Thank you, McCune, 46. So you need to figure out, okay, if the ancient Egyptians were painting pyramids, would they paint the bottom of their pyramids where the sand is? Probably not. So I wouldn't paint down there either. Okay, now really quick, McCune, because my brain's a little fried, do 46 times 9 so that we can get our lateral area for that. Off to the side here, I'm going to find the area of our two triangles. 1/2 base times height, 9 times 12. And since I have two triangles, I'll double that answer. Thank you, McCune, 414. So then here we're going to have 54. I have two triangles. That looks kind of weird. It didn't even autocorrect. Well, whatever. Two triangles is going to be 108. So we're going to take, yeah, paint is no good with sand. Trust me, I've tried before. So our final answer is going to be 522 meters squared. Now, even though I say how much paint will he need, we're talking surface area. We're talking how much of the surface of this house do we need to paint. Next to the A is a little triangle, so it's like a subscript, area of a triangle. I'll clean that up. Ooh, oh, that autocorrect. Great. Area of a triangle. McCune, if I leave you to B, would you be able to do parts B and C as well? Or would you need to go over those as well? No, the colored papers are due next week when I see you during your actual final exam. Ethan, do you need help with part B and C, or do you think you could try it on your own? You need help with all of them, Isaac? Okay, we can totally do that. So let's think about this. If a gallon of paint covers 150 square meters, how many gallons of paint will we need to buy? Now, the hint I've given you guys is that, no, this is the green paper, Mateo. The hint I'm giving you is sort of the lollipop principle I went over last time in class. Oh, sorry, Isaac. I'll still talk about it. So the lollipop principle, I like to say, is that if you have a class of, let's say, 36 students, and I'm buying boxes of lollipops for the class so that each student gets one lollipop. Well, depending on how many lollipops are in a box, you would always have to buy a whole number of boxes. You can't just buy part of a box. So if I say that there are 10 lollipops per box, I would need to buy 4 boxes. Even though there's 4 leftover lollipops and no one is getting any extra, I still have to buy that extra one. So the same idea is going to apply here. We know that we have our surface area that needs to be covered. And we know that there are 150 square meters that can be covered by 1 gallon. So we're going to go ahead and divide those. Now you can do that and you'll probably get something like 4 point something. Or you might get 3 point something, I don't know. I actually do know, but whatever you get, decimal wise, you round your answer up so that you get a whole number. Let's go ahead and jump over to number 2 that Mr. Nick wanted to do. All right. Correct, Mateo. So the free response final, I'm grading like I would your normal tests. It's going to be partial credit. You're going to, show all your work that you can to get the most points and get as many of the answers correct. When you do your multiple choice final, those are all right or wrong. No partial credit. So that's what you'll be doing. Okay. So right here, a person, an apartment sites the top and bottom of a building 500 feet away. So that means the distance between these is right there. You get the formulas for the multiple choice, not for the free response. The angle of elevation for the top of the office building is 23 degrees. So that means that right here, 23 degrees. The angle of depression for the base of the building is 50 degrees. Oh, that was a beautiful 5. There we go. Now we want to figure out how tall this building is. Well, if I separate my triangles, the height of the building, let's call this X and this Y. I need to find the sections, the heights for both of those sections and add them together. So here's my 23 degrees. Here's my 500. So for that triangle, we're going to say sine of 23 degrees because that is the opposite. Wait, no. I lied. It's not sine, it's going to be tangent. Because we have the opposite and the adjacent. And yes, Isaac, we could go ahead and do number 8 after we do number 3, after we do number 2. So tangent of 23 is going to equal x over 500. So x is going to equal 500 tan 23. Now, while I'm setting up the next part of the triangle, I want someone over there to go ahead and do that on their calculator. The other triangle we're going to look at is right here. So that's 50 degrees. This is our 500, and this is our y. So on this one, same idea, we're doing opposite and adjacent. So that's tangent of 50 equals y over 500. So y is going to equal 500 tangent of 50 degrees. I believe for the free response it's going to be 8 questions. It will be somewhere along the lines of, like, some of the questions will have one or two parts, and the others will just be just normal questions. Thank you, Dylan. 212. I'm gonna keep those digits. And hopefully someone else got the other one, the y equals 500, tangent of 50. Now, Dylan, I am a little hesitant on doing 5b simply because I did it in class already. I can answer any specific questions about 5b for you, but I would rather not do the entire thing over if I can avoid it. Thank you, Nick. That is 595.8767. Okay, someone over there on the other side of the computer screen, go ahead and give me what x plus y is going to equal. $807.8767. Now, in the problem, we say round to the nearest foot, so that means round to the nearest whole number. So what Sarah would probably round it to is 808 feet. So there you go. So let's see here. Let me make sure. So Dylan, to answer your question without going to it, if I'm telling you that the water raised a quarter of a foot, that means that the height of the water going up is a quarter of a foot. So you're going to calculate the area, or sorry, the volume of the water that changed. So your height is going to be 1/4 of a foot. You're still going to use the same base area. Okay? Thank you, Sarah. Thank you, Nick. Thank you, Dylan, for helping me with the numbers. Now, I know I need to do number 3 next. Then I promised Isaac number 8. All right, so let's do that. Number 3, we have our fire truck. We know that the ladder goes out 100 feet, and the height of the truck where the ladder comes out is 8 feet. So if the ladder's greatest angle of elevation possible is 70, what is the highest above the ground that it can reach? So that means I want to solve for this total height here. To get that total height, we need to incorporate the fact that part of the height creates a right triangle, while the other part of the height comes from the distance between the ground and the truck. So this is 8 feet no matter what. I'm going to hold that off to the side, and we're going to incorporate it into our answer in the end. 70 degrees is our angle of elevation. The ladder is 100 feet long. We want to figure out the height, so that means I'm looking for this side here. So that side over there means the opposite and the hypotenuse. So oh, wait a second, that's going to be sine. Sine of 70 equals x over 100. What's up, Farid? Yes, we can do 4b when we have the chance. Although I feel like I might have done that already. I don't remember. I'll check. So then here we're going to have 100 sine of 70 equals x. So Sarah, I believe this was your question? Yes. So go ahead and type that in your calculator, and then we'll proceed onward. Only 12 people are watching. That's okay though. I'm willing to help you guys out however you need, because you're all awesome. You thought it was going to be x minus 8? Oh, you meant x plus 8, yeah. Thank you, Ruff McGruff. Yeah, keep 4 decimals afterwards, just, you know, just because. And then you're going to add 8 to that. So that's going to be 101.9692. Round into the nearest foot, so 102 feet. Yeah, that's all we need are the 4 decimal. Sweet. Okay. Isaac, I think, where did Isaac's question go? Gotta make sure I get it right. Come on, YouTube chat, stop being weird. Number 8. Yeah, number 8. Okay. So let's take a look at number 8. Then we'll jump to 4B. Yeah, for it, I already did that one. I did that one like right at the beginning of the video. But I'll jump back to that one in a bit. Ah, yes, the infamous cake problem. Oh, yes. So I know I gave everyone the hint at the beginning of class about that problem. So let's go ahead and work it out. I believe I've given you the diameter of all the cakes. So 24, 18, and 10. So that means my radius for this bottom cake is going to equal 12. The radius for the next one is going to be 9. And then the radius for the top one is going to be 5. Yeah, it is a pain, Isaac, but I believe in you. You're a smart guy. You are Isaac Newton. Although if the other Isaac heard me say that, he might get jealous, but that's okay. It's not his fault. Yeah, we can go over number 5 just in case. I need sleep. Okay, so for the first part, lateral area plus base 1. Yeah, no problem, Fred. So layer 1, we're going to be using for the lateral area 2 pi RH, and we're adding on the area of the base, which is going to be pi r squared. So right away we have 2 pi 5 times 6. The height for all of these cakes is going to be 6, so that's going to be at least convenient, plus pi times 6 squared. So that should give us 60 pi plus 36 pi, which will be 96 pi. That's layer 1. Layer 2, let's use a different color. Layer 2 is going to be, again, 2 pi RH. We're going to use a different radius and a different, I don't know why I said a different height. They're all the same height. We're going to use a different radius for this one. We're adding on base 2, which is going to have the radius of the new cake, but we're going to then subtract from it the area of our base that we calculated up here, because that part of the base, oh my gosh, I just dropped my mic. Ugh. Cool. that part of the base is covering the other base. So pi r squared minus our 36 pi. Okay, so now plugging in the radius for 9, we're going to have 2 pi 9 times 6 plus pi 9 squared. So let's see here, 9 times 6 is 54, 54 times 2 is 108, 108 pi, plus 9 squared, which is 108 pi, minus 36 pi. Why did I say 9 squared was 108? That's 81. Bad, Mr. T. Okay. Isaac, I think you asked this question, so go ahead and do that entire thing. Add them all up for me and give me that answer. While he's doing that, we're going to set up layer 3. So again, layer 3 is going to have a different radius. If you only know the formulas and don't actually know how to use them, you're not going to do well. If you know when to use the formulas and what the parts of the formulas mean, you will do very well. Thank you, Isaac. 153 pi. So now layer 3 is going to have a radius of 12. So that's going to be 2 pi 12 times 6 plus pi times 12 squared. And then we're going to subtract from that answer the area of the previous base. So that base would be this 81. So minus 81 pi. So Isaac, in a bit, I'm going to have you combine those terms for me. So that's going to be 12 times 12, 144 pi, plus 12 times 12, 144 pi, minus 81 pi. This moment of silence was brought to you by math. 207, yeah. So let's see here, 207 pi. So Isaac, my dear friend, here's what you're going to do. Your last step. You're going to take your 96 pi, your 153 pi, your 207 pi. You're going to add them all up. So Dylan, type in 144 plus 144 minus 81. Dylan. You're typing in 144 plus 144 minus 81. And thank you, sir. Isaac, hopefully that was of help to you. I hope so, my little dude. Of course, I could have just typed it out. He would have seen the numbers right there, but that would have been too easy. Now, technically, if we want to be correct, we should put inches squared. All right, Isaac, it was nice to have you joining us. On the test, do you want us to convert it to inches or leave it in terms? You're going to have both. Pi is not a unit. Pi is a measure. Think of it as a variable. So if you were to actually multiply out pi, you would get an exact answer. Or sorry, not an exact answer. You would get out an approximate answer, but usually leaving them in terms of pi leaves the problem clean to get exact values. Adam, you want to look at 9b, but I think I said we were going to look at a couple other ones too, so give me a second. I really wish these things would just highlight. I don't even remember which one we're on. Oh yeah, number 8. So this is 8. For B, we were going to look at later, because I already did it. Oh man. I need to find a way to integrate like a question button where when you ask the question, YouTube registers, oh, this is the question number, and it creates a timestamp. That'd be kind of cool. Okay, because I'm lacking the brain cells right now, let's go ahead and take a look at 9b. Because I've covered a lot of these already. Yeah, let's take a look at 9b. Okay. We ask you to find the surface area and volume. Now for this one, Adam, you have to remember that the figure is laying on its side. So the base is actually going to be this side over here. So two things we need to get from this. We need to get the perimeter of our base, which is going to be 6 plus 6 plus 6, or in this case 6 times 4. And luckily for us, that's also going to be the same base over here for our pyramid. Yes, Rough McGruff. If you go onto the notes link, you will open up my OneNote link and it'll show all the work that I do. And I'm not done doing a solutions guide. I will be done once we finish this video. So that should help out. Alright, so there's my perimeter, my area of my base atom. Remember, it's a square, so that's going to be 6 times 6, which is 36. You're welcome, Rough McGruff. So for my surface, you have to remember that I don't have that face because it's covered by both the pyramid and the prism. So for my prism, which is kind of weird. For my prism, it's going to be lateral area equals perimeter times the height. Our height in this case is going to be the distance going away from the base. So that's going to be 24 times 8. Now, I'm going to have you type that in your calculator. No, you do not get the formulas tomorrow, Nick. You're going to type that in your calculator, Adam. My surface area is going to equal my lateral area plus 1 base, because the other base is covered. So once Adam tells me that answer, we'll be able to proceed on with getting the surface area for the left side. My boy, 192. So then Adam, go ahead and do 192 plus 36 and tell me what that gets you. While he's doing that, let's look at the pyramid. The pyramid is going to be lateral area equals 1/2 of the perimeter of the base times the slant height. Our slant height is given, it is a 5. So that is going to be 1/2 24 times 5, 228. Thank you, Adam. Sweet. So now again, Adam, you know what, I'll do this one. 1/2 of 24 is 12. 5 times 12 is 60. That's our lateral area. Do we need to do surface area? Well, remember that a pyramid only has one base. And this base is covered. It's covered right here. Covered. So we don't need to do surface area because the base is covered. Now for both of these, I need to cover their respective volumes. So the volume of my prism is base area times the height. Oh my goodness, why are you being weird, Microsoft Word? Base area times the height. So that's going to be 36 times 8. Again, Adam, you're going to go ahead and do that in your calculator. For the volume of my pyramid, that's 1/3 base area times the height. So that's going to be 1/3 of 36 times, wait a second. We didn't get the height of the pyramid. It wasn't given unto us. What are those? Thank you, Adam 88. Really? That can't be 88. You might have typed something in wrong. There we go, 288. Okay, so over here we still need to find the height of our pyramid. Our height is going from the vertex of our pyramid to the center. Now, because I gave us the side length here of 6, that means this part here, I didn't mean to do that, this part here is going to be a length of 3. This should look awfully familiar, y'all. It's a Pythagorean triple. So we're just going to plug that in. 1/3 of 36 times 4. So now to answer the actual question, it says find the surface area and volume of the composite solid. So that means we're going to take our surface area answer here with our lateral area there. So for my total surface area, that's going to equal 228 plus 60, which is 288. And then for my volume, we're going to take our 288 and our 48. Oh, that's not a good color to use with those. Let me try pink. Yeah, that's not too bad. Yee, we wear pink on Wednesday. So, volume, total volume, that's what I meant to write. (288) plus 48. So I believe that is, no, that can't be right. 2. Is that right? That just looks weird. I guess it's right. Okay, Adam. I'm glad I was helpful. I hope that's right. And of course, what the... Did I undo something? 288. So those units, did I write them in? Inches. Inches squared. Inches cubed. Alright. Trying to think here. We already did this one. Oh, we're almost done. Okay. Well, if anyone has any other questions, they can ask me now. Got to go. Good night, Sarah. Hope you're doing well, my child. And then there were 8 brave souls. I almost want to give you guys extra credit, but I can't. 5A through D and 9A. Oh yeah, I'm gonna definitely need some sleep. I am so exhausted. Okay, so we'll do 9A, then 5A through D. And I think I may call it a night just because it's already been over an hour. And my brain cells are basically done at this point, as I'm sure most of yours are. But hey, there's light at the end of the tunnel. Summer vacation, woo! Okay, I'm gonna fix that. Cool. Yes, I teach math. What is your superpower? So, Charmaine, my child, we're gonna do the same thing here as we did on the other one. What we might want to do is find our height for this cone right away. Since we have our radius of 5, that means this is also 5. This should look awfully familiar too. Now, going back to the similar idea of the other one, you have your base here covered. So that means in our cone, we're not going to do the base area for that. And for our cylinder, we're going to only do one base, and that base will be the bottom here. That's the only one we can actually see. And live stream on the yellow packet. No, Dylan, I'm not doing any live streams on the extra credit packets. Those you have to do on your own. But you can work with your friends. You've got all weekend. You have a 3-day weekend. Why? Okay. So then for our cylinder, we have lateral area equal to 2 pi RH. So 2 pi times 5 times 12. 5 times 12 is 60. 60 times 2 is 120. My surface area, remember, is going to be our lateral area plus, we took care of one of the bases, so that means it's only plus B. But wait, we know the area of the base because that is a circle. So the area of a circle is pi r squared. So 120 pi plus pi times 5 squared. Last thing for this one, we have the volume. So the volume of our cylinder equals pi r squared h. So pi times 5 squared. Oh, that's weird. I thought I saw a cat in the corner of my house. Times the height of 12. So that one, 25 times 12. Why can't I math right now? I think that's 300. I'm going to need you to double check that, Charmaine, okay? Because Yeah, check 25 times 12 for me. Now for our cone, our beautiful cone, our lateral area is going to equal pi r L. So that's going to be pi times 5 times 13. Probably be easier if I zoomed in. Oh yeah, much easier. $300, yay, I was right. So 13, 26, 39, 52, 65. 65 pi. I do not need the surface area because the base is covered. So now all we have left for the cone is the volume. Volume equals pi r squared times h divided by 3. Or if you want to say 1/3 base area times height, that's fine too. That is totally fine. Here we go. Pi 5 squared times the height of 12 all over 3. Can Mr. T do this in his head? Probably. 12 divided by 3 is 4. 5 squared is 25, so that's going to be 25 times 4. 100 pi. So now, to finish off the problem, we're going to take our lateral area from here and the surface area from here, add them together to get the total surface area. Now, Charmaine, you're going to add those two together, and you're going to tell me what that gives you. And while she's doing that, we're going to write down the volume, the total volume, which is going to be our 100 pi plus 300 pi. Now, does Charmaine get it? No, not yet. We are waiting for you, Charmaine. Go, go, go. Inches. So volume is inches cubed. Surface area is going to be 210 pi inches squared. Okay. So there we go. That was 9A in all of its majestic and infinite glory. Is anyone inviting me to any math conferences? No. I'm very sad. There's a chance I may go to Portland in the summer to do a math conference, and I am awaiting for their reply. Okay, so rough McGruff, we will go over the rest of number 5. Good job, Charmaine. There we go. We got it in screen. Yes. We'll make this one the last one unless anyone requests anything specific. Okay. So you got 5A. Now here's the deal, Rough McGruff. There are two ways to look at this problem. You can look at this and say, hey, if the height went up a quarter of a foot, that means the new height is 15.25. So the volume of your tank would be base area times the new height, but then you're going to subtract the volume that you got from the original problem. The other way of looking at this is saying, well, the height only went up a quarter of a foot, so that's the displacement of the water. So that's the height of the water going up. So that's a little chunk of our tank here. So you can look at this in one of two ways. You can look at it as a new height minus the old volume, Or you can look at this as a different height and finding the volume from there. That's supposed to be a 0.25. That looks not so pretty. Much better. So then on part C, how many rocks fit? There are a couple ways of doing this. You could say, well, 1/4 of a foot was the height going up. Well, I need to fill up a total of 5 feet. Yes, Alyssa, I can do number 1. So how many times does 1/4 of a foot go into 5 feet? It would go in 20 times. Or I could say, well, Mr. T, I have a volume of 75 cubic feet. I have to fill in the space up here. And the space up there is the total volume of 6,000 minus the 75%. Yes, Sam Esquibez, I can look at letters A and C. So then I would also get the same thing of 20. For letter D, we have a new tank. These new tanks are of size 5 by 12 by 4. So I want to figure out how many of these tanks could I fill with the amount of water that I got in part A. Well, the volume of these new tanks are 40 cubic feet. So I'm going to take the amount of water from the original part of 4,500 and divide them by 40. That will get me 112.5. But just like the lollipop principle that I was telling you about, you can't just use part of a tank. Like you can't just say, I need 112.5 tanks. You need 113 tanks overall. So that's why we round our answer for this one. And even if it was something like 112.2, you would still round it up to 113 because how many tanks do you really need? You need that extra tank. So that's what we do for that one, Rough McGruff. Okay, good. Alyssa, we're going to jump to number 1, and then Esquibez, we're going to look at number 4. There are 2 triangles we have to look at here. We have to look at this small triangle here, and then we have to look at the overall big triangle here. For the small triangle, that height of W is what we're going to solve for, and for the bigger triangle, we're going to solve for the total height of Y. Now for the small triangle, they give us the angle of elevation is 55 degrees. And we're solving for here. So we're going to go ahead and set up our trig ratio. Tangent of 55 equals W over 1,000. So W is going to equal 1,000 tangent of 55. So Alyssa, go ahead and type that in your calculator to get the value of W. Now while she's doing that, I'm going to set up our other triangle down here. Alyssa, were you able to type that into your calculator? She's probably scrambling right now to find her calculator. Yeah, that's really small. It should be slightly bigger than 1,000. Do you want to check your calculator, Alyssa, and make sure your calculator's in degrees and not in radians? Or possibly gradients, depending on how you messed your calculator up. You might want to do that. Also, don't type in inverse tangent, because that's not good either. So, Nick, you got W. Alyssa, make sure you get that answer, because that looks correct. Oh my goodness, I wish I could see your calculator. There's usually a button at the top that says mode. Hit the mode button and then find DRG, degree. Or is it DGR? I don't remember. I think it might be DGR, degree. Or even DEG for degree. Now, while we're trying to help out Alyssa, Nick, or anyone else, go ahead and calculate that for us real quick. $27.47. That's a lot of 7s and 4s, huh? Oh no, I didn't write small enough. Oh, I don't even know why I'm doing that. I should just erase it. 2747.4774 minus 1428.1480. You fixed it. Yay, Alyssa! Okay, now Alyssa, you have to redeem yourself. Do y minus w. And tell us what x equals. Don't write your answer, Nick, because I know you already got it. Just write it down on your paper. Why is my computer being done? Okay, never mind, we fixed it. Alyssa! Yeah, there it is. Perfect. 1319.3294. Now, of course, we don't need all those decimals. Round to the nearest foot. So x equals 1319 feet. Okay. Alyssa, I hope that was helpful to you. I'm going to help out Sam Esquibes with for A and C. Oh man, it's already an hour and 18 minutes. At this rate, I'm not going to get any more grading done. I'm going to just fall asleep right here on my couch. Okay, so 4A and 4C. Alright, so you're welcome. Sam, we're going to need to find our height of our pyramid. That's going to be 6 because it matches up with the 12 and that gets split in half. So then, oh no, I lost it. We're going to need to solve for h. So h squared plus 6 squared equals 10 squared. If you recognize this Pythagorean triple, you should know that this is 8. So lateral area, 1/2 the perimeter times the slant height. Since our base is a square, I can just do 12 plus 12 plus 12, or just 12 times 4. I meant to keep the orange. Yeah. So 1/2 of 48 times our slant height of 10. So I believe that's 240. Surface area is going to equal lateral area plus one of your bases. So our base area is 12 times 12. Oh my gosh, what the heck was that? Which equals 144. So that'll be 384. Now for our volume is going to be 1/3 base area times the height. So that's 1/3 of 144 times 8. Now I'm no super genius, so I'm going to need Sam to do that in her calculator. And while she's doing that, I'm going to take a quick gander at letter C. So it's basically the same thing. The only thing different is I don't give you the slant height, so we're going to need to solve for that. There's my bottom side, which is going to be a 12. My slant height is going to be this here. So that's going to be, boom, 384, my girl. Okay. Wait, they're both the same? What? Yeah, sometimes they're the same. Pyramids are kind of weird that way. Okay, so now here we can do another Pythagorean theorem. 9 squared plus 12 squared equals slant height squared. Again, this is another Pythagorean triple. Common theme here, guys. L is going to equal 15. Now, if you're uncertain whether it's going to be a special number, just do the whole Pythagorean theorem. There's no harm, there's no foul. Okay, just do it. I should have Nike sponsor me. Okay. So there's my slant height. We have the height already given to us. Let's find the base area. The base area, since this is a square pyramid. Oh, I should probably get the perimeter too. The base is going to be 24 times 24. I don't want to do that in my head. So I'm going to have Sam do that. The only other thing we need is our perimeter. And let's use light green. The perimeter is going to be 4 times 24, which is going to be 96. So, lateral area 1/2 perimeter times the slant height. So 1/2 of 96 times 15. Now surface base area equals 576. Thank you. Cool. Because we were going to need that in a bit. Surface area equals lateral area plus 1 base. So that's going to be whatever answer we get before. I'm going to again leave that to you all. Go ahead and do that. That answer plus 576. Boom. Volume 1/3 base area times the height. So 1/3 576 times the height of 9. 720. So then 720 plus 576, 6, 9, 12. 1296. Did I give the units? No. So this will be units squared, and we still need the volume. So go ahead and calculate that volume. Well, I know 1/3 of 9 is 3. So then 3 times 576. But, you know, type it in your calculator. Just go ahead. Do 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 do. 1728. That sounds right. 1728 units cubed. All right. So there we go. Happy go lucky. Or is it lucky go happy? I think it's happy go lucky. Pretty sure. All right. Any other last minute questions, my little critters? Take a look at what we've covered. We've covered a lot. I'll finish up these questions once we're done. You're welcome, Sam. Yeah, we've basically finished the entire thing. So I'm going to go ahead and upload these completed solutions guides into the online notes. 6A. We already did 6A, my little child, but there's the work we did. I will upload everything into our updated version of the worked out stuff. So in the thing it'll say solutions. What unit are all these formulas? Do you mean all the formulas for this entire packet? Because technically we've done a lot of stuff from Unit 9. I'd say mostly Unit 9 and Unit 8. These are mostly where these formulas are. Adelina, you're welcome. I kind of wish that YouTube would tell me who was actually like exactly online, because right now it says for watching. So I can assume Alyssa, Adelina, Charmaine, and Samantha. I can assume you 4. Even though it might be less, it could be more, I don't know. I don't know who else is on. Okay. Cool. Alright. At this point, I'm going to go get things ready for you guys. And yeah, I will catch you all tomorrow. And I promised someone I'd be silly, so here we go. Don't forget to hit that like button, hit the subscribe, and make sure you hit that bell button to get the notifications whenever the new videos come on. Okay, there, I did it. This will be probably the last video I do for you guys for this year. At that point, I have to figure out what am I going to do for next year when I have new students, because obviously you guys don't want to be bombarded. You were the first one, Adelina? Nice. Obviously when you have new kids, like, you don't want to get notified, oh, Mr. T's online, because then you guys, you know, you don't need to watch it. So I'm going to figure out how that works. Would I force you guys to unsubscribe, or would I have to make a new channel or something? I don't know. I will figure it out. I'll figure it out as I go along. No, Alyssa, don't cry. You are not allowed to cry on me yet, okay? You can cry next week, okay, after I give you guys your gift. I have a special gift for all of you, okay? Also, I have my yearbook in the classroom. I finally got my own copy. And I want any of you that want to sign it. Okay. I'm going to bed now. Or at least I'm going to try to. I probably won't, but I'll try to. I'm not teaching Algebra Virginia next year. I'm sorry, Charmaine. I believe in you, little critter. Alright. Good night, y'all. See you tomorrow. You might take up a whole page. Oh my gosh. No, you can't take up a whole page. You have to share with everyone, okay? Bye.